Okay, now we are going to be evaluating definite integrals with the u substitution method. So first thing we're going to go ahead and do is find the antiderivative, and then we'll deal with the bounds at the end. So given that first function, notice that my inside function will be the x cubed plus 8, which is what I have. And then remember we said we need the derivative of that, which is 3x squared, and I move that dx over right away. So start with that. And we're going to rewrite the integral in terms of u. So this becomes u squared. And then let's see what we have left. X squared dx. So if I solve this for x squared dx, oops, notice that du over 3 is x squared dx. So I have du over 3. So I'm going to rewrite the integral, pull out the 1/3, and then I have u squared du. Now, there's two ways you can do this definite integral. One of the ways is to go ahead and change the bounds. You can go ahead and, if we're going to rewrite everything in terms of u, we need the bounds to match the u variable also. So this original bound is x equals 0. So I need to know, x equals -2. I need to know what's this bound going to become when x is 0, when x is -2. So when x is -2, if I plug in -2 there, -8 plus 8 gives me this new u bound of 0. That's how I get to the 0 here. And then the upper bound, notice here, was x equals 1. So when x equals 1, if I plug in 1 here, 1 plus 8 is 9, so there's my new upper bound of 9. So that's how I get my new bounds. So now, instead of rewriting it in terms of x's, you can go ahead and take the antiderivative using your u. So I would have 1/3 u to the 3rd over 3, and I can go ahead and use my new bounds here. I'm going to rewrite this as 1/9, and then I have 9 to the 3rd minus 0. Really, I end up with 9 squared, which is 81. So this is one way you can do the answer for the definite integral. The other way you can do this is you can go ahead and switch it back to your x's. So if you want, okay, let me get rid of this. Instead of doing these bounds, just go ahead and take the antiderivative. So it'd be 1/3 u to the 3rd over 3. But I want to keep the bounds of -2 to 1, so then you would have to plug back in what your u is, which is x cubed plus 8. And then you can keep the bounds of -2 to 1. So if you do not change the bounds, you can go ahead and replace with the x's and keep the same x bounds. And if you plug this in, you'll get the same answer of 81. So it's up to you how you want to do it. But on this page, I'm going to just practice working with the new u bound so we get used to that. Okay, so number 1. My inside function is x squared plus 1. Remember we talked about when you have things on the bottom, raised to a power that's not 1, bring it to the top. My du here is going to be 2x. I'll bring that dx over. So let's rewrite it in terms of u. So this becomes u to the -3. I have x dx, so really du over 2 is x dx. So I've got du over 2. And I'm going to rewrite this like this, u to the -3 du. Pull that 1/2. I'm going to figure out my new bounds. The first lower bound was x is 0. When x is 0, I'm going to plug it in here to figure out the matching u. U is 1. And then the upper bound was x was 2. And then again, plug it in here. If I plug in 2, your u ends up being 5. So these are going to be my new bounds from 1 to 5 of u to the -3 du. So now let's take our antiderivative. Add 1, divide by the power. I have my u bounds, so I can leave it in terms of u. Let's clean this up before I plug things in. Bring that u squared to the bottom. So I will get -1/4. I'm going to pull out that -1/4. I have 1 over 25 minus 1 over 1. So I'm going to leave my answer like that. Second one, so there is an antiderivative for secant squared. That means your u has to be the angle. The du is just 4, bring that dx over. So let's rewrite it. So I've got secant squared of u. Du over 4 is the same as dx. So I've got du over 4. So I'm going to rewrite it here. So I've got 1/4 pulled out, and I've got secant squared of u du. Okay, let's figure out our new bounds. I know that when x is pi over 24, that's what I started with here. I'm going to plug it in for u. 4 times pi over 24 is pi over 6, so there's u. And then when x is pi over 16, if I plug it in, u ends up being pi over 4. So those are my new bounds. So it's pi 6 on the bottom, pi 4 on the top. Antiderivative of secant squared is tangent, so 1/4 tangent of u. So since I changed my bounds, I do not have to plug the u back in. So I've got 1/4, pull that in the front. Tangent of pi 4 is 1, minus tangent of pi 6 is √3 over 3, and I'm going to leave my answer like that. Okay, last one. Your u is the inside function, which is 4 minus x squared. Your derivative is negative 2x times dx. When I do this problem, anytime there's numbers just being multiplied, I do like to just go ahead and pull that in the front and just think of it like this. So don't worry about that -8 for right now. So let's do the rewrite. So this gives me square root of u. And then I have x dx. So if I solve this for x dx, just divide that -2. So I have du over -2. I still have that -8 in the front. So this is what I have. Now let's clean it up and rewrite it. So really, -8 over -2 gives me a 4 in the front, and I have square root of u du. Okay, let's go ahead and find our new bounds. The lower bound was x equals 0. Let me get rid of this. So when x is 0, what's u? 4 minus 0 is 4. When x is 2, your u ends up being 0. So notice this was the lower bound. So the 4 is here, the 0 is here. So let's go ahead and take my antiderivative. So add 1, divide by the power is the same as multiply by 2/3. And my new u bounds were 4 to 0. And let's clean this up a little. I've got 8/3. And then if I plug in a 0, I've got 0 minus 4 to the 3/2. Let's just practice our simplifying. 4 to the 3/2. So the square root of 4 is 2. 2 cubed is 8. So I have a -8. So this is going to really give me -60 over 3 as my final answer.